It might seem crazy what I'm about to say.
When calculating with moles, there are some basic terms you need to know. First thing you need to know is that an atom is the smallest part of an element, molecule is the smallest part of a covalent compound, and a formula unit is the smallest part of an ionic compound. These will be used throughout our calculations. Avogadro's number is described as the number of particles per mole of a given substance. It is defined as 6.022 times 10 to the 23rd. We use Avogadro's number often in chemistry. We use it when converting particles to moles, moles to particles, grams to particles, and particles to grams.
I should probably warn you, I'll be just fine. No offense to you, don't waste your time. Here's why, because I'm happy. Clap along if you feel.
Now we're going to talk about calculating with moles. In the first example, they are asking for how many atoms of calcium are in 3.00 moles of calcium. You would start out with 3.00 moles of calcium and multiply by 6.022 times 10 to the 23rd atoms of calcium over 1 mole of calcium. The moles of calcium would cancel out and you would be left with 1.81 times 10 to the 24th atoms of calcium. In the next example, they are asking for how many atoms of zinc are present in 0.250 moles of zinc. You would start out with 0.250 moles of zinc and multiply by 6.022 times 10 to the 23rd atoms of zinc over 1 mole of zinc. The moles would cancel out and you'd be left with 1.51 times 10 to the 23rd atoms of zinc. Now we're going to show some examples of calculating with moles and molecules. In the first question, they are asking for how many molecules of sulfur dioxide are present in 0.118 moles of sulfur dioxide. You would have to start out with 0.118 moles of sulfur dioxide and multiply it by 6.022 times 10 to the 23rd molecules of sulfur dioxide. That would be put over 1 mole of sulfur dioxide, and the moles would cancel out and you would be left with 7.11 times 10 to the 22nd molecules of sulfur dioxide. In the second example, they are asking for how many moles of ammonia are in 7.52 times 10 to the 23rd molecules of ammonia. You would start out with 7.52 times 10 to the 23rd molecules of ammonia and divide it by 6.022 times 10 to the 23rd molecules of ammonia. That would cancel out and you would be left with 1.25 moles of ammonia.
How are moles related to mass? The atomic mass in grams is the mass of 1 mole of a given atom. For example, 1 mole of carbon is 12.011 grams. First, calculate the number of atomic mass units in each of the following. First, we have to change 2,500 atoms of zinc into atomic mass units. Next, we look at the periodic table and notice that zinc's atomic mass is 65.41 atomic mass units. First, take 2,500 atoms zinc and multiply it by 65.41 AMUs. Then divide 1 atom zinc, which then cancels out. This calculates to 1.6 times 10 to the 5th AMU. The next question asks to calculate the number of atoms in 8,620's atomic mass units of carbon. Next, you have to find on your periodic table the atomic mass of carbon, which is 12.011 atomic mass units. Start out with 8,620 atomic mass units of carbon. To cancel out the atomic mass units, you have to divide by 12.011 AMU's carbon. The atomic mass units cancel out, and you're left with 718 atoms carbon.
To find molar mass, first you have to determine the moles of each element in the compound. Then you have to calculate the total masses of each element, and finally you add the total masses together. First example is what is the molar mass of silver nitrate. First you have to find the formula of silver nitrate, which is AgNO3, and then determine the number of each element that are present. Then you have to multiply each subscript by the atomic mass, and when you add all the atomic masses together, you get the molar mass.
When calculating percent composition, first you determine the molar mass, and then you calculate the percent by mass of each element. In the first example, you are determining the percentage of sodium in sodium hydroxide. The first step in finding the percent composition is determining the molar mass. The molar mass is 40.00 grams. The formula for percent composition is grams of each element over the molar mass times 100. To find the percentage of sodium, you place 22.99 grams of sodium over 40.00 grams of sodium hydroxide, multiply it by 100, and get 57.48%. The empirical formula can be determined when the percent composition or grams of an element is given. First, you calculate the moles of each element. Then, you divide the number of moles of each element by the smaller number of moles. Next, you write the whole numbers as subscripts in the formula. Last, if the answer is a fraction, multiply it by an integer to obtain a whole number. What is the empirical formula of a compound containing 27.3% carbon and 72.7% oxygen by mass? When calculating the empirical formula, you have to recognize that in 100 grams of carbon, there is 27.3 grams of carbon, and in 100 grams of oxygen, there is 72.7 grams of oxygen. To calculate the empirical formula, you have to determine how many moles are in each substance. To find the moles of carbon, you divide 27.3 grams of carbon by 12.01 grams of carbon to get 2.27 moles of carbon. To find the moles of oxygen, you divide 72.7 grams of oxygen by 16.00 grams of oxygen to get 4.54 moles of oxygen. The second step is to divide by the smaller number of moles. Since carbon has a smaller number of moles, you divide 2.27 moles of carbon by 2.27 to get 1.00 moles of carbon. Next, you divide 4.54 moles of oxygen by 2.27 and you get 2.00 moles of oxygen. To determine the empirical formula, you place the results of the previous calculation next to each element to get CO2, also known as carbon dioxide.
You can calculate the molecular formula when the empirical formula and the molar mass are given. First, calculate the mass of the empirical formula. Then divide the molar mass by the mass of the empirical formula to obtain a small integer. Lastly, multiply by the empirical formula by the integer to determine the molecular formula. Lactic acid has an empirical formula of CH2O. If the molar mass of lactic acid is 90.08, what is the molecular formula of lactic acid? The first step is to find the molar mass of the empirical formula. The molar mass is 30.03 grams. Second, we use the formula molar mass over mass of the empirical formula to find a small integer. 90.08 grams divided by 30.03 grams equals 3. Lastly, you multiply the small integer by the empirical formula CH2O, which equals the molecular formula of lactic acid, C3H6O3.
Why are moles important to chemistry? The mole is a basic unit in chemistry. Without the mole, you cannot convert from particles to moles, moles to particles, particles to grams, or grams to particles. Without the mole, you cannot count atoms, molecules, or ions.
Why formulas are important? Formulas are essential to chemistry. One small error in the writing of a formula will result in incorrect calculations.